The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody. Welcome to this afternoon seminar, which is about automating with IBM SPSS. I'm sitting in a very dark office in London town. I hope it's a bit brighter wherever you are, but thanks for joining this afternoon. Just before we get into the main content, a few questions, a few FAQs for this session. We are recording it, so if you'd like a recording to review, we will certainly supply you with one of those. We will also send through a copy of the slides in PDF format to your email not long after the session has ended. Obviously, any questions that you have during this session, all the lines are on mute, but you can use the chat facility in the webinar, in the GoToWebinar, and ask us questions. My colleague Rachel, who you can't hear right now, but she's behind the scenes and she will endeavour to answer your questions. If there are any that we just run out of time to answer, we'll of course get back to you after the session. And if you'd like a rerun of this session or a version of it which is perhaps more specific to your context and questions, then yeah, we'd be very happy to talk about that as well. And you know, we can run it online, and potentially we can even come into the office and see you. So today's seminar, I'll start with a little bit of background in terms of what we're trying to achieve. We often, I think that the sort of title of this seminar said that it seems like it's something of a secret that you can't actually automate at all around SPSS. We often find that sometimes, you know, long-time users of SPSS are unaware of the range of possibilities that do exist. And of course, it's not for everybody. So I think hopefully what we can do here is try and articulate some of the possibilities of automation, as well as some of the ways in which you actually do that. And the short story, as you'll see soon, is that there isn't just one way, there are different ways, and you may find one is more suited to your requirements. So we're going to talk about syntax and streams. So we're going to talk about both types of SPSS today, both flavors, SPSS Statistics and SPSS Modeler. And they have automation options that are different, partly because they are, as I'm sure you know, very different types of software in terms of their user interfaces. So the sort of core automation for both is using syntax and streams, and we'll touch on that to start with. And then we'll talk about how you go beyond that. So how would you automate effectively at a higher level than just, for example, using syntax in SPSS Statistics. And then finally, we'll talk a little bit about how you can automate from the outside into SPSS. So primarily what we're talking about here is setting up automations inside SPSS that can be run inside SPSS or can be run as background processes. And then finally, we'll talk about how effectively you can create automation that calls into SPSS and maybe calls into some other applications as well. So what we want to try and achieve today is to talk about, certainly at a high level, what the different types and levels are when it comes to automation in SPSS. You may already have some automation ideas or challenges or thoughts, and if you do or you don't, we hope it allows, because it's about the art of the possible, we hope it starts to sow some seeds of what you might look to do, and then also to start to give you an indication of what you need to do it, because there's likely to be some coding in this if you're going to move to automation that somebody needs to do. So what kind of coding skills do you yourself need or your colleagues need? And finally, what's around to help? And the good news is there are an increasing number of resources, because this is a developing area, that are available to help you start doing automation yourselves. So why do we automate? Well, you know, here are a kind of series of potential reasons to do that. I guess the top one tends to be the one that we think of first, which is it becomes faster and more productive if we automate. In some circumstances, it has to be, of course, around something that hits on the second point, which is repeatability. So we have to have something that we're going to run a number of times to make it worthwhile investing the build and development time to create the automation in the first place. The other reason is that it means that what we get is potentially more governed. It's more quality assured. Essentially, it's less likely that we'll have errors, assuming that we build it and test it correctly. It's also a way in which we can delegate, and you may have heard the term, which comes from Gartner, actually, called citizen data scientist. We talk a lot. You'll hear a lot about data scientists, and I'm guessing there are some data scientists on this call. The idea of a citizen data scientist is somebody who can do data science without necessarily having to understand some of the intricacies of algorithms, or indeed necessarily having to understand code. So automation also allows us to build automation pieces that can embed expertise, if you like, and be passed on to colleagues who need to use them, but don't necessarily need to understand some of the sort of statistical nuances. So let's talk about the different levels of automation, and let's begin at the first level, which is different depending on whether you're using SPSS Statistics, which is shown on the left, or SPSS Modeler, which is shown on the right. As you see already, I'm sure many of you will be using one or both of these. They have very different interfaces in style. SPSS Statistics in some ways is more classical windows in the style of menus and dialog boxes. Modeler is more about drawing workflows or streams, as they're known, and visually creating jobs that allow us to run data flows, build models, and test them, and so on. So the type of automation, the first level of automation that we talk about in SPSS Statistics is syntax. Now, I could give you a figure, but not all SPSS users use syntax at all, and some just dabble in it, and certainly would use, not necessarily write syntax from the ground up, but would use the PACE facility, which we'll come on and talk about, which I'm sure many SPSS stats users are aware of. And then we do have some users who are syntax first. And once upon a time, I'm not sure if we've got any long-term users on the call, but once upon a time, syntax was the only way to use SPSS. There were no menus. So we do still have some users who prefer that method. Although I think there's a strong argument that even if you are proficient at coding, the menus actually help you build syntax more efficiently. We'll talk about that a little bit. On the other side, the stream, which isn't code, of course, the modeler stream, the visual flow, we often describe it as visual programming because it is a way in which we build effectively a job. So over here, we might build a syntax file, which is an analytical job. Over here, we might build a modeler stream, which is an analytical job, but it's a more visual job. Nonetheless, it is a piece of automation. So the stream you see in front of you here will take data from, in this case, a text file, and we'll run it through a series of steps and produce some outputs. And that can all happen at the click of a button or potentially on a scheduled basis. So the stream itself is a level 1 automation, as indeed is the syntax in SPSS Statistics. I mentioned pasting, and the good news, I'm sure many of you are aware of this already, is that if you're in SPSS and you're using the visual menus and dialog boxes, if you want to create syntax at any point in time, so you can make the selections visually in the dialogs, then you can click the paste button. Pretty much every dialog box in SPSS, not every, but almost every dialog box in SPSS has a paste button, and that will create the syntax. And that syntax then can be saved away in a file, and it is something that can be run and automate a series of steps that otherwise would have been or can be created using just point and click. If we want to get help on syntax, so let me just switch to SPSS here so I can demonstrate this then. And what I'm going to do is I'm just going to specify that I want to open a file. So I'm just going to execute what we saw on the slide there. I'm just going to pick a particular file. I'm going to click paste. And I'm going to go to syntax file. Excuse me, it's just on the other screen. I'm just going to move it over. So when we click paste, we get a syntax file that looks something like this. And if I want to, for example, run a regression, I can start to define the regression. In fact, I just need to let me just run this command here. And then I can start to define a regression. Let's make it a linear regression. Just using the dialog boxes. I won't go all the way here. Actually, what I'm going to do is just switch data files. Let's put a data file here for a regression. We'll come back to this regression idea a couple of times later because we're going to look at how automation allows us to run different types of regression. But I've got, if I just show you the labels, I've got 3 satisfaction measures here, and I've got an overall satisfaction here, and I can start to set up a regression, and I can say, for example, it's an enter, and I can get the bones of the regression together, pretty much specified as I want it to be in the dialog box. Then I can click paste, and there is a command which has the blue is the command, and the slash greens are the subcommands, and the slightly off red words are keywords or specifiers around the subcommands. So if I suddenly realize that actually I've got the wrong kind of method in here, let's say I want a stepwise method, I can always go back to the dialog box, change that and reset it. But the other thing I can do is I can hit control space or control at any point in time, and I should get a pop-up in the relevant place in the command that tells me what other options are available there. So if I knew I was looking for stepwise, I can pick stepwise and away I go. I may not have known that that's the option I want, in which case I do need to go into more depth. And the other way we can do that is, again, we can go back to the dialog box, or in the help system, we can go to the PDF manual and go to the command syntax reference. The command syntax reference is a PDF file, and within that, it's all sorted in alphabetical order. I can go down and find regression, and within regression, I can see the options, and I can see what the different methods are in more detail. So there's a lot of help and resource available, of course, if I want to start to create syntax automatically and then build it up and append it. What if we forget to paste, which we often do? You know, somebody who uses SPSS Statistics a lot, this happens to me a lot still. Maybe it happens more to me now than it used to, I don't know. But there are other ways in which that syntax gets recorded. In fact, it's getting recorded all the time. So unless you decide to change this option in Edit Options in SPSS, you'll find that there is a file being written somewhere which is just accumulating the syntax for the stuff that we do in point and click. And that's called the journal file, and that can be opened at any time, and we can go and look at the syntax and take whole sections of syntax and put them from the journal, put them into syntax files in SPSS for Windows, and effectively we can recreate our automation path from there. And beyond that, and this is something which is, again, some of you I'm sure will be aware of, but it doesn't appear or appear to appear, if that makes sense, when we run an analysis in SPSS, but we usually get a notes window which is hidden. So in the SPSS output viewer, I'm sure you're all familiar with this sort of, it has this kind of book metaphor, and the idea is that you can open and close books. So if I go back to my my regression, I will actually run it, and I'll show you the outputs here. Then there's the regression output, which is probably pretty meaningless because I didn't really think about what I was doing when I specified it. But you'll see there is a notes book down here that is closed, but I double click it and it opens. And that's meant to be part of the audit trail of the analysis, as I'm sure many of you know. So it tells me whether I've got any weights on, whether filters are applied, and so on. But within there is the syntax that was executed. So I can literally, if I want to grab it, if I can't get it from the dialog box, then I can highlight it and pull it out. It's reusable, so I can paste that again into an SPSS syntax file. So when we create syntax files, the easy way to run them, of course, is we save them away and we open up a new SPSS session in the future and we open up the syntax file and we can rerun it. Sometimes we want to go to the next level when we're running automation, and we may want to run multiple syntax files at the same time in sequence, and we may want to run them at a certain time of day or night. We may effectively want to run them without having to open SPSS at all, and that's what the production facility is about. So this is something you can open. It's really a separate application, you might say. It's found in the utilities menu under production facility, and as you can see, what it allows you to do here is to stack up, effectively specify one or more syntax files that you already created, and to specify some options about what happens if something goes wrong. Where do you want the output to go? What type of output do you want to create? Do you want to create it as a normal SPSS output? Do you want to just send it to a text file, and so on? It also has this option, and we'll see this a little later when we look at some of the automation in Modeler, but it gives us the option to use parameters, runtime values as it describes them here. And these are values that we might want to plug in to the syntax, and that change every time the syntax run. And the obvious one is something related to date. So it might be that we want to run the syntax once a month. There's a bit of road rage going on outside. I think we can hear it. Apologies for that in the background. There is the option to say let's create a parameter in the syntax which will take the month, and every time we run this we can pass in the current month, and that might drive a particular select if or some other syntax that's dependent upon that parameter selection. I said that we can run in batch, effectively in true background mode. We'll see this again in a second when I show you running batch from the command line. But if you created a syntax file and you want it to run without opening SPSS at all in a background mode, then you really do need an SPSS Statistics server to allow you to do that. So this particular option within the production facility asks you to select an SPSS Statistics server to run the job in a true stealth-like hidden background mode. And directly linked to that, there are two batch engines. So again, this might sound like a slightly arcane term, but the idea of a batch engine is, as opposed to the normal way in which we work with SPSS, which you might think of as interactive. So we open up either Modeler or Statistics and we interact with the interface. So we open up syntax files and run them, or we use them with dialog boxes and so on. There are two engines. One is called Statistics B, Statistics Batch, for SPSS Statistics, and one called CLEMB or CLEMBatch, because many of you will be aware that SPSS Modeler used to be called Clementine for SPSS Modeler. So the way that they work, and again, it's a server-side thing, is we can specify if we've got syntax or we've got streams, depending on whether we're using Statistics or Modeler, we can alternate them, or we can effectively run them without opening up the SPSS Statistics menu system or the Modeler user interface. And I'll show you a little example. Let me just run a job myself. So I'm just going to go to my command prompt. So here I am. I'm working on the server. If I just do a dir, so this is this is just using the command prompt within Windows. So for those users who remember it, this is effectively using DOS commands. So there are a few commands that we need to be familiar with. I've got a syntax job here called KDA1.SPS. KDA, for those not familiar with it, stands for key driver analysis, and it effectively means we're using some form of regression analysis. And I'll come back and give you some other examples of KDA shortly. Excuse me. And I've got an output file here called KDA1.txt. So I'm just going to delete that so you'll see if this appears. I can spell it right, KDA1.txt. txt. Oh. I have to get my DOS commands right. Del is the right command. So if I do a dir now, you should see the KDA txt is gone. So what I'm going to do is I'm going to run statistics B. So I already tested this command earlier, just to be on the safe side. So I'm running statistics B, which is the SPSS batch engine, SPSS Statistics batch engine, and I'm specifying using what they call switches, command line switches. -f is what is the name of the syntax file I want to run. What type of output do I want? So I can produce output in different formats, like HTML, for example. Here I'm just going to specify a text output, and I'm going to name the output file to be the file name that I just deleted, which is kda1.txt. So kda1.sps is a syntax file I've already created. It opens a data file and runs a regression, and when I run it, we won't see SPSS open at all because we're effectively using what you might think of as the SPSS engine and not the SPSS menus. So I should now have, I'll do a dir again, a new version of kda1.txt, which you'll see is timestamped 1521, which is just now. And I'm just gonna, it's just a text file, so I'll just type it to the screen so we can have a look at it. I can go and open it in an editor, but I'll stay in this window here. And I'll use this little option to show me a page at a time. So anybody who used SPSS pre 2000 maybe will recognize this is what the output used to look like. So it's just rather dull text output, actually probably earlier than that, but that's the result of the regression, and it's the same tables, but a different format to the tables we'd see if we ran this interactively in SPSS. So the good news about using statistics B is you can start to move towards, and indeed the same is true in the production mode, we can start to move towards running SPSS jobs in a higher level, in a more automated way, where we could use, for example, the Windows scheduler to say, do this at a certain time of the night. So run this once a day, run it once a week, run it on a schedule, and effectively run this command and generate this output. So using syntax as the first level of automation, we can then use that syntax in a batch mode. There is a next level of automation which goes beyond that and works both with SPSS Statistics and with SPSS Modeler, and in actual fact probably visually looks more like Modeler than SPSS Statistics. And this is something called IBM SPSS Collaboration Deployment Services. And what we find usually when we work with SPSS customers, new customers and existing customers, is usually collaboration deployment services isn't the first way that you do automation. You probably do something more like the batch processing that we just talked about to start with. But you get to a certain point, perhaps, where you're doing so much automation that it makes sense to have effectively a platform to help you do the automation and control it, and have a central repository for all the analytical assets, as they're known, so for all your modeler streams and your SPSS syntax files. So I want to, there's probably a separate seminar all about collaboration deployment services in itself. But in this particular example, you can see we're actually running several modeler streams. They're initiated by a message coming from another system. So it starts to get quite technical once we get into the world of CADs, albeit, you know, this is something that usually the analysts and data scientists administer and learn how to sort of set up these jobs as they're known. And at each stage, if something goes wrong, there is a notification that gets sent to somebody. Often it's an email, can be another way of just triggering an event that tells somebody that something succeeded or failed. And at the end of this flow, there is an SPSS syntax file. So this is if you like, a sort of next generation way of creating automation jobs, which can be scheduled, they can run on demand, they can run in real time, in some cases they do, but they allow you to take syntax streams and create automation flows. There is a kind of a scaled down version of collaboration deployment services. You might think of it as a C&DS-Light, called the PS, which stands for Predictive Solutions CLEMENTINE PRO, which has its own scheduler. So it allows you to do something similar where you can create jobs and syntax. Sorry, you can create jobs from either SPSS syntax or from modular streams, and you can store them in a repository and you can schedule them and run them. And it has its own architecture with which to do that, which is very similar to the modular architecture, sorry, the collaboration deployment services architecture, which is all based around the fact that you have a database effectively, which is where you store your SPSS syntax or your modular streams. And I won't go into any much more detail about this, except to say that storing our automation pieces, syntax, and so on in a database is actually a good idea. There's something of a tradition in the world of analytics, data science, of saving files, saving them on file shares, having our own systems for creating different versions, and every analyst has their own little siloed repository, which is really just a series of folders on a disk somewhere. So moving to this style of, first of all, automation, which is mainly what this is about, obviously has its benefits, but it's also good because it means that analytical assets, which are often quite important to our organizations, are stored in a secure database, are backed up properly, are versioned properly, and so on. So that's it as far as the first level of automation, which is about syntax in SPSS Statistics, streams in modular. We can build those up, we can automate the creation of those to some extent, and then we can put them into production in different ways, if you like. So we can put them into the production mode or run them as batch jobs and schedule them and so on. What if we want to go further? You know, is there another level of automation beyond syntax? And again, many of you might have found that there are challenges with syntax where you get to a certain point and actually you can't do what you need to do. So it might be that, you know, for example, you want to talk directly to Excel or PowerPoint. Now, actually, syntax is getting extended, and there is more of that capability within syntax itself. But there are often situations where the automation that you need is beyond the ability of a syntax file or a modular stream. So what this gets us into are either other programming languages, really, which is what the final four are: Visual Basic, Python, Java, and R, or macros, which I'll talk about first, that are within SPSS syntax, but they are a particular branch of SPSS syntax, if you like. So I know we talk about macros in Excel or in other Microsoft Office products. They have a particular meaning in SPSS syntax, which we'll touch on shortly. So the reason we go to this next level, as I just started to allude to, is that we want to create reusable blocks of code. Sometimes we want to create our own dialog boxes. We'll see some examples of that shortly. And often what we want to do is build bigger automation. So it doesn't just involve SPSS, it might involve a database, it might involve some other Microsoft Office products, or indeed any other application. So let's start with macros as one way of doing this. And you might decide, I'm going to start and look at macros and see if macros just give me that extra level that I'm looking for. And often they will, but not always. What's good about them is that they are really an extension of SPSS syntax. So if you become familiar with SPSS syntax, then macros repackage or reuse syntax in a slightly different way. So they run inside SPS files, syntax files. On the flip side, they are syntax, but they're not. They have their own kind of rules, and you have to learn how to use macros in a different way to the way that you typically use syntax. They are also not as powerful at all, really, as, for example, Python or indeed Visual Basic or Java, which are some of the other options that we have when we hit the buffers with, particularly with SPSS syntax. So what do we mean by macros? Let me show you a few examples. Here's a really simple one, perhaps the simplest macro that you can create, which is saying a macro is always headed by or started by a defined command and finishes with an end-defined command that has an exclamation mark at the beginning, a bang. And we usually call our macros with an exclamation mark at the beginning as well. We usually name them, I should say. So I'm sure you've all been in the situation where you have a path name in a piece of it. Those of you who use SPSS syntax in SPSS syntax, which probably repeats a number of times down the syntax as maybe you open multiple data files or save different data files and so on, and you may be joining them together or aggregating and doing all sorts of data preparation stuff with them. So if the folder changes or the directory changes, then you can do a search and replace. So you could just open up the search box, the edit box, and type in what you want what the old directory location was and what you want the new one to be. Probably a better way of doing that is, in a sense, to just create that folder name once. So it's, in a sense, it's like a parameter, which we mentioned earlier. So this would effectively create a parameter called my folder or exclamation mark my folder, and I can give it a name once, and then I can refer to it at different points down the syntax. So this is just doing a get file where I'm opening a file called census.sav, but it will replace, and that's really one of the key things about macros, that in a sense they are doing a kind of search and replace. It will replace the word apostrophe my folder with ctrain syntax 2. So that's a really simple example, and you might just find that's just an extra useful thing to do if you're already using syntax and you face this challenge of having to do lots of search and replaces, because it just eliminates that. It means you just need to change that folder name in one place, which of course is better practice. A more sophisticated one could be, we're almost creating a new command, and that command is inevitably built up of other commands in SPSS. So it might be that you have a particular kind of regression that you always run, and you always have to go in and set several different subcommands and options to get that regression. So what you want to do is just say, look, I just want to create that as almost like a template, if you like. In this example, what we're saying is, I'm going to create a macro called close all, and what that will do is it will close all data sets and it will close all output Windows output viewers according to options that I specified. Just in the same way that we specify subcommands and options to regular SPSS commands, we can create our macros which will take the same kind of subcommands and options. So it will only close the data sets if the data set option is set to yes, and it will only close the viewers if the viewer docs subcommand option is set to yes. So that's the way that we set up the macro. It begins with a define and an end define. It's called close all. It has two subcommands to it. The first one is data sets, the second one is viewer docs. So to run it, again, we just use the name of the macro, which begins with the apostrophe. We do that, by the way, typically so we can distinguish between what is a built-in SPSS command and what is really a macro command. And if I say close all data sets equals yes and viewer docs equals yes, then that will effectively run both blocks of code, and it will do a data set close all and an output close all. So effectively what we've done, thinking about levels of automation, is we've taken syntax, which is already a type of automation, the first type of automation in SPSS Statistics, and we've added in another level where we're running multiple syntax commands in one by just specifying one macro call. So those are macros, and as you can probably see already, if you haven't looked at them before, they do have their own variation, if you like, of SPSS syntax. So it's something you need to look for. By the way, I'm sure many of you know this, but often, you don't necessarily have to build these things from the ground up. You can go and look for examples that are close to this that maybe exist already, and sure, we all tend to do this now when we're working with the wonderful world of Google and the internet. We'll often find code examples that we can take and adapt, and not use them as is. So the other choices when we're looking at extending or automating to the next level are not macros, which are essentially SPSS syntax variations, but to use different languages. So VB, Visual Basic, Python, Java, and R are the main choices. There are some others as well, especially if you're automating from outside SPSS, which we'll come back to. The advantages are that they are, you might say, quite well-developed programming languages. So they have lots of functionality and they are quite widely used. So of course, they're not just used for SPSS, they're used for building applications in some cases, and they're used, in the case of VB, for example, as the way that you do macros inside Excel and PowerPoint. So they allow us to add a lot more. They're more flexible and powerful, and they go beyond just automating SPSS, potentially, which is often what we need to do. We want to automate across multiple applications. Downsides, they're not really running inside SPSS, although it appears, and we'll see an example shortly, that we've got a script, a VB script or a Python script inside SPSS. So we have to link them to syntax in the case of SPSS Statistics. And I guess the other point is that you need to learn, or somebody has to have these skills. So somebody has to be able to use Visual Basic or Python or Java or R. You might counter that by saying, you know, there are, as I'm sure you're aware, lots of new graduates, for example, and lots of people who are retraining to be able to code in one or more of these languages. So it is becoming much more widespread and ubiquitous. So here's an example of a VB script. And if you're interested in looking at the VB option, there are lots of example scripts within that are installed with SPSS, and I'll talk about some resources shortly that you can look at to get more detail. There's a site called Developer Works, which I just realized isn't in the slides, so I'll add it to the slides before we send them over, because that's often where you'll find, you know, forums and communities where it's a community which has some forums that have some code examples that you can use. So this is an example of and you can see already, if you haven't looked at this before in SPSS, it starts to look more like Excel, and the way you do things in Excel if you move to that macro level. And this is an example where we're actually calling a script that will check through a correlation table and will highlight any cells in that table that are statistically significant. So it looks at the p-values and it changes the color of the cells. So the kind of automation that we couldn't do just using SPSS syntax. Now, I've largely been talking about SPSS Statistics up until now. Let's think a little bit more about Modeler in this context. What's happened recently for those using SPSS Modeler has been that Python has effectively been integrated into Modeler. So there is a slight kind of fork in the road at the moment, because there was already a scripting language in Modeler. So a little bit like SPSS Statistics has syntax, Modeler had its own scripting language, which we now refer to as the legacy scripting language, where Python is now the new scripting language. Modeler also has the ability to, also has facilities and nodes where we can call R as well. So R is again, I've referred to it, but I haven't really described what it is for those who haven't encountered it. R is a statistical language, which is all open source, as indeed, of course, is Python. So to give you an example of scripting, I'll give you two examples of scripting inside of Modeler. It's interesting for those of you who use Modeler already. I suspect many of you haven't necessarily looked to use scripts. It happens much more quickly in SPSS Statistics that you move to use syntax to do automation, because of course in Modeler the stream itself, although it isn't code, is, as we mentioned earlier, a form of automation. So here's an example. Actually, this is legacy code. We'll see some Python code later of a script that will effectively start from a blank canvas, so an empty stream, and will build the stream. So it will effectively add the nodes to the stream, put them in certain positions, and then it will run them in order. So it's actually going to add a data source node, type node. It will run a table so we can see the data, and then it will add a modeling node and actually run that modeling node. It's adding a chain node and it will run it. So let me just show you that script in action. I'm just going to go to Modeler. Let's bring Modeler over here. So here's my empty stream. I'm just going to go to a standalone script. So this is that. I'll just maximize that. This is the script that we just looked at on the screen. What I'll do is I'll just move it over here so we can see things happen. So I'm just going to select to run. So it's a blank stream. I'm just going to select to run it, and you'll see it's building the stream, and you'll see data is flowing. That's what the green lines are. I'm sure modeler users already know this. And then it effectively runs the model. So this isn't me pointing and clicking, although it might appear as it is. It's actually the script effectively simulating that point and click. And it's building a chain model now on this telco data, which I think should be finished in a minute, 83% complete. So effectively it's doing that modeling. So an example of this is we have some users who use scripting on top of modeler streams to automate the building and testing of lots of different models with slightly tuned parameters. So sometimes they're running thousands of models to try and see which one gives them the best results. But it is the next level, the second level of automation beyond the stream itself. That was using legacy scripting just to show you what a Python script would look like inside modeler. I'm going to go to an existing script that's in here. So let me just show you this data first. So this is already a partially built stream, let's say. It's data from data on telecommunication customers, and we want to sort of explore and analyze it, maybe model it in different ways. If I just run a graph on region, you'll see that there are, if I can find it, there are 4 regions. Just reading the data from the source file. So they're labeled regions 1 to 4, but they could be, north, south, east, west. So I can, in the usual style, if I want to analyze them separately within modeler, I can select each region separately, create a select node, link that into the stream, and run it off in different directions, and maybe do different kinds of analysis for different regions. Well, since modeler 17, I think, we can do that using scripts. So if I just show you the script that's underneath that. Now, again, the good news is that when we're doing things like looping, which we're doing here, we want to rerun the same analysis for each region. When we're doing this level of looping, we can effectively build the loop, which says I want to loop on different regions, and I can paste that syntax, and what it will create is, sorry, I need to click paste. What it will create is the actual Python script. So this doesn't cover all the Python scripting you might want to do in modeler, but it does, this is one way, rather like pasting SPSS syntax, that we can create the Python script, and we can potentially adapt it from here if we want to. And again, I can just run that, and what you'll see is on these particular nodes here, it's effectively doing the looping I was starting to do manually, and selecting out each region separately, and just running a matrix, which is effectively a cross tab in modeler. But that could be then doing anything. We could be running different models for different regions and testing different things. Okay. The next type of automation that I'll talk about sort of picks up from where we just were in terms of, in order to build extensions, then there is a built-in facility called the custom dialog facility in both modeler and SPSS Statistics, which allows us to use Visual Basic or Python, or in some cases R, to effectively build our own dialog boxes that automate above the scripts, if you like, or above the syntax. They allow us to effectively create our own visual analytics in the same way that we have dialog boxes in SPSS. And this is an example which potentially touches on that idea of the citizen data scientist and creating more user-friendly or user-appropriate dialog boxes for colleagues to potentially use who are not necessarily as excuse me, statistical, let's say, in some cases. So this can be done using Python and R. And more recently, this can be done in modeler, at least, using Apache Spark, which has its own algorithms, and this is one of the new kind of big data platforms. So in terms of what that looks like, here's an example, a KDA extension in SPSS Statistics itself. So this looks like, at first glance, this looks like an SPSS dialog box, but actually it isn't. It was created, developed by a partner of ours called the Channel Group in the US. And this is something you can actually find on the Smart Vision site. So this is something, if you do KQ drivers, you can download this from the Smart Vision site. We have quite a few users of this already. And what it does, I'll just run it again in SPSS itself, is we've actually put it on a separate menu called Custom, but it doesn't have to be there. We can put it wherever we like in the menus. When we run it, it pops up and looks a lot like, I've already made my variable selections here, but it looks a lot like a kind of simplified SPSS dialog box. And when we run it, it runs a regression effectively. So it's a bit like the regression I ran earlier. What's different is it then automates the extraction of the key values from the regression itself and builds a plot, a quadrant chart in this particular example, which is one of the standard outputs that it's usually market researchers who use key drivers analysis. This is one of the outputs that they often deliver to their clients. So in order to do that normally in SPSS, you would have to, it's a bit of a faff, if I'm honest with you, you'd have to take the values out of this particular table here, the beta values, you usually put them in Excel, you do some calculations with them to get these values. You'd also have to look at some mean values as well. So there's a set of steps that you need to do to produce this. So that KDA extension is automating above those several steps. We could create a version of it that produces this output in PowerPoint or Excel. And again, that's the kind of automation that's possible when we're using Python or Visual Basic. So there's another example where we actually use more variables in the plot and it starts to come to life. So the idea is that you're focusing on this quadrant here because you've got some very important drivers that you're performing not so well on. In recent years, the SPSS community or the IBM community, IBM SPSS community has started to build more and more extensions, and it's a growing list. There are more of them out there. So I'll show you shortly where to find them if you haven't looked at this particular repository before, so I'll come back to that shortly. There is the link to Dev Central or Developer Works that I mentioned. I'll check that link is still live because IBM have been changing the site a little bit. But in there you will find discussion forums about automation and development, and you'll find some good examples of code. And often that's the best place to start when you're looking to automate. Here's one now that was originally just an extension, but if you've got SPSS 23 or 24, it's now part of the family. So as long as you install the extension add-ons, you will see this as if it's a standard menu in SPSS. And this is a data preparation example where you can take a categorical variable like labor force status, working status in this example. You can run it and dialog will, underneath the hood, it will use Python to create dummy variables effectively, so dichotomous variables that will be 1, 0 for each category of the nominal variable. I mentioned earlier, for those of you who haven't looked at it necessarily, there are lots of particularly statistical algorithms and methods in there, some of which are not available in SPSS yet. So we can call R from within SPSS syntax, and to do that, we use syntax and we specify a little bit like the way that we have define and end define. We say begin program R and end program, and there we can embed our code. So again, back to a point we made earlier, you will need to you either need to learn the R code or go and get it from the internet, or have a colleague who can code in R to do this. But you can directly have SPSS syntax that is doing SPSS stuff and then goes off and, for example, in this case, runs something called a Shapley regression, which is another kind of key driver analysis, which has gained a lot of traction in recent years. But this is also an example where, and you will find this a lot now in SPSS, that with every release, there are a number of different often statistical algorithms being added in that come from either R or Python. And often they'll have different iconography inside the SPSS menus. So what I just showed you, pre-23, you could code the relative regression yourself into relative weight analysis, into the SPSS syntax. Post-23, it's an option you can select from the SPSS menu, from the analytics regression menu. There is if you like, a more kind of user-friendly way to look for what extensions already exist. And the good news is that these extensions can also be the basis for you to adapt and create your own automations. So the Extension Hub, which you can get to off the extensions menu in SPSS Statistics and in Modeler, has a searchable interface to go and look for different types of extension. And this is a growing list that's been created by IBM themselves and IBM partners, users and customers. And it's also available on GitHub. For those of you who are familiar with that, that's kind of in a sense, the most popular repository for developers around the world to post their open source statistics, analytics, and many other kinds of programming resource. So that's really all about using different languages inside of SPSS or inside of Modeler. I'm just going to finish off by talking about another set of possibilities, but effectively using the same kind of coding. So using a combination of, it might be syntax, Visual Basic, Python, or indeed R. So what we can do is we can create our own apps, if you like, our own pieces of software. So this is a really simple one that has, from the user interface perspective, just has a small number of selections, but it's used to process signals coming in from sensors inside houses. But underneath the hood, it runs SPSS, it runs some statistics, it runs some SPSS charts, and it processes them into JPEGs and PDFs that are distributed to engineers. So you never see the SPSS interface here. It's running SPSS in the background. Another example of that, so this is an application that runs in a browser. It's a graphical a GIS app for local planners. So this was an example where we had a group of planners in the local housing department who were using SPSS to do a factor analysis to assess sustainability in different areas around the city. So we effectively took their SPSS analysis and embedded it behind a web-based application that was written in Java. So the different colors on the chart show you different levels of sustainability. Those levels are arrived at by a whole series of factor analyses that are run according to a particular method that creates indices. And it's visualized not for statisticians, but for planners. So the statistical work is done, it's embedded and automated behind the web-based user interface. So just to summarize then, I think it sounds like almost a glib thing to say, but it is possible to automate probably much more than SPSS users are typically aware of, and there are lots of reasons to do that. There's a lot of value in the kind of analysis that SPSS brings, and automating around that and making it more productive, and perhaps spreading it to a wider audience and making sure that it's done in a more controlled and governed way clearly has additional value to us using SPSS just on our desktops. But there's always going to be a cost-benefit discussion. Is it worth doing? How long is it going to take us to build that automation, because it is effectively a development? And does that stack up? Is this something that we're just going to run 4 or 5 times, or is it something that we want to run 20 times? And what will that time saving be? Does the investment stack up? So that's the main content for today. Just to finish off, I'd like to just explain a little bit about who Smart Vision are for those of you who haven't talked to us or worked with us before. We effectively work in 3 main areas. We do provide software and technology. We are a premier IBM SPSS partner. We increasingly work in the world of open source, and as I'm sure many of you know, IBM is very much embracing the open source world. We talked about R and Spark and Python earlier. So we often work with our customers to help them decide which software is best to solve particular analytical problems. And we'll run projects, if you like, that are not necessarily designed to be outsourced analytical projects, but to help you get up and running. So we do lots of training and skills transfer and enablement. And what we typically like to do is have a pilot project that gets you up and running and actually proves some value at the same time. So we might be building some models or some automation that you can then take and enhance and take off into the future. And we also like to think the final point is that we're not always on the clock, as it were. So if you have any questions and you just like a chat, and in this context of automation, you may have an automation idea and you're not quite sure yet whether it's something that needs to be done using syntax or Visual Basic or Python in Modeler, then we are very much open to have those conversations and maybe point you in the right direction, and it may bring us back into some of the other services that we offer, or it may not. So thank you very much for your time on this Thursday afternoon. I hope you found it useful. We'll send the slides along later, and if any of you ask questions and you didn't get them answered, then please do send us an email. You can send one to info, and one of us will respond back or give us a call. Yeah, hope to see you, potentially, again, either in person or online in the future. Thank you very much.